Hi there, welcome to N7.3. This outcome is all about the relationship between decimals and fractions and whole numbers. So remember that decimals and fractions are numbers that are less than 1. So if you've got a decimal number like 0.45, that is less than 1, right? And fractions, we've always said, part of a whole. Now, make sure when you're spelling the word whole that you put a W on it. I've seen some of your entries in the journal. It was like a hole in the ground. So, part of a whole with a W. So, we've learned quite a bit about fractions and decimals, and now we're just talking about how they're related. So you need to know how to put them on a number line and how to, I'm going to jump right to the bottom of the page here, recognize the benchmark fractions. And so this last one is saying if you have a number line from 0 to 1, because remember everything is going to be less than 1. So here's your 1, here's your 0. We know who lives here, right? It's a half, which is also known as 0.5. Okay? And so you can order the rest of the decimals based on what you know about those benchmarks. Okay? So back up to the top. Predicting the decimal representation of your fraction based on a pattern. So knowing the decimal equivalent of 1/8 and 2/8, so you should be able to predict what 7/8 is. Okay, I know that 2/8 is the same as 1/4. I know that 1/8 is exactly half of that, and so you should be able to place something like 7/8 on a number line. Matching fractions to their decimal representation, and we've talked a bit about those benchmarks that you really need to know, like this guy. What's the decimal representation for 1/3? This is something that you should have memorized. It's 0.3 repeating, so 0.3333333, right? And then double that. If I have 2/3 instead of 1/3, I'm doubling it, and so I can double my fraction, or sorry, double my decimal. 0.6 repeating, so 0.66666, etc. Knowing if a fraction is repeating, like these two were, or terminating, which means it ends like this guy did down here, 0.5. Explaining how terminating decimal could be written as a repeating decimal. Well, here you go. Here it is. Right? Zeros could repeat. Expressing a fraction as terminating or repeating, expressing a repeating decimal as a fraction, expressing a terminating fraction or terminating decimal as a fraction. So all of these are just saying kind of the same thing. There's one or two strategies and you'll be able to do all of these things. Providing example of where a decimal representation is an approximation. Okay, so with your repeating decimals, if I just rounded this off and said it was 0.3, that's just an approximation because it's not exactly 0.3, it's actually 0.33333 forever and ever. So sometimes we just have to round it off and call it a day, right? Putting numbers in order, and you'll need to know these two words. This is something you can put into your journal if you want. Ascending means it's going up. Descending, the D, remember that, is going down. Okay, so ascending order would be starting with your lowest and going up the scale or up a number line or whatever. Getting bigger. Trying to find a number that would fall between two decimals or two fractions. So with fractions, you end up having to break it down into a bigger denominator so that you can find more pieces within. And for a decimal, you end up having to use one more decimal place to find numbers that fall between two decimals. And I will show you an example of those coming up. And again, talking about putting them on a number line and knowing your benchmarks. Here we go. Okay, so when you are converting a fraction, such as 7/8, into a decimal, There's two ways you can do it. You could just simply type this into your calculator because a fraction bar means what? I hope you said divide. Okay, so 7 divided by 8. Okay, if you're going to use a Dave, remember that your bottom, your big old bottom, sticks out because it's so big. Oh my God, your bottom is so big. So I think we had a good chat about Kim Kardashian here the other day. So we know that the bottom of the fraction is the one that sticks out of the Dave, right? It does not go inside the cave, it's on the outside. All right, now I should have left myself more room, but we'll squeeze her in anyways. To figure out what 7 divided by 8 is, we ask ourselves, does 8 fit into 7? Well, no, does not. But we can continue this 7 by putting some zeros on. And the decimal that you have inside the Dave needs to have his decimal bunk buddy up there right above him. So make sure that they're lined up nice and straight. And then we can continue on here. Does 8 fit into 70? Well, yes, it does. It goes 8 times, so we're looking at 0.8 something, something, something. We're going to subtract 70, take away 64. Right? Bring down our 0. Does 8 fit into 60? Goes 7 times. Okay, so everybody in the Dave is happy. They all have somebody on their top bunk, except we still have a remainder. So we could still keep going with this decimal. So we're going to go one more 0 to bring down. Does 8 fit into 40? Yes, it does. Okay, it goes exactly 5 times, and there's a 0 left over. So when you get to the point in your Dave where everybody inside the Dave has a top bunk buddy, right? Everything's looking good there, and you have 0 as a remainder, then you know you are done. That's how you know you're done a Dave. If you never get 0 as a remainder and it seems like you're going forever and ever and ever, that's when you have one of those non-repeating, non-terminating, so it never ends and it never repeats, it just keeps going. That's the kind of decimal that you're working with. So at some point, you're going to have to stop doing that question and round it off and call it a day. Okay, here are the need to knows. When we're talking about thirds, you need to know that it's 0.3 repeating or 0.333 repeating, whatever. 2/3 is 0.666 repeating or 0.6 repeated, same thing. So we could also write it like this, 0.3 with a line above it, 0.6 with a line above it. And in the outcome, I believe they call this bar notation. Bar notation, which just means the bar is drawn above it, okay, to show that it repeats. Okay, when we're talking about quarters, this purple chunk here, you need to have these, this entire page memorized basically. You need to know that a quarter is 25 cents. So 1/4 equates to 0.25. A half is the same as 0.5. 3/4, just think of money, it's like 75 cents. If you have 3/4 in your hand, you have 75 cents. Looking up here at the blue guy, 2 divided by 10. Anytime you're going to divide by 10, 10 has 1 0. So that means you're moving your decimal place back 1 spot. And that's how we got the 0.2. So if I'm dividing by 2 zeros, I'm moving my decimal place back 2 spots. Okay. Knowing when things are out of 50 that we could just double both sides, or both top and bottom, and we would end up with a number that's out of 100, and that's easy to do the division on. We just have to move the decimal back 2 spots, just like they did right there. And you should have your fifths memorized as well, and the fifths have a nice pattern. 1/5 is 0.2, 2/5, see the pattern? 2, 4, 6, 2, 4, 6, 8, and a full 1 right there. Okay, turning a decimal into a fraction. So we just figured out how to turn a fraction, 7/8, into a decimal by using a Dave. So going the other direction, turning a decimal into a fraction, you need to count the amount of decimal places, which equals the amount of zeros in your denominator. So they've given us this decimal, 0.35. Well, how many decimal places are showing here? So I ran right over the decimal. It's right there. So we have the tenths and the hundredths. So altogether, a number like 0.35 or decimal 35, because it's showing two decimal places, the tenths and the hundredths, we always name decimals by the last decimal place that is showing. So we would say this is 35 hundredths. And well, there should be an R in there. Yeah, there we go. Hundredths. Awesome. Okay, so if we're going to call this thing 35 hundredths, does it make sense to you that we're going to put a fraction like that, 35 over 100, or 35 hundredths? So when you see two decimal places in the decimal, then you're going to put 2 zeros in your denominator. Okay, let's look at example 2. 0.7. So how many decimal places are showing? Just one. So how many zeros in the denominator? Just one. What is the name of this here decimal? Remember, we're going to name it by this place value, the very last one that's showing. And that place value is the tenths. So this is 7 tenths, which then makes sense that we are putting the denominator as a 10. All right, let's talk about pi. Looks delicious, doesn't it? So pi is one of those weird and wacky decimals that scientists have puzzled over for years and years and years and years, and they are still trying to figure it out. It, to our knowledge, does not repeat. There's no pattern within pi at all, and it does not terminate. It goes forever. It's one of the few decimals that does that, and it's just been puzzling scientists and mathematicians for centuries. So anyways, at some point, I think it was either Euclid or Archimedes, I can't remember, probably Euclid, he figured out a fraction of 22 over 7. I'm going to change pens here. And he called that close enough. And so for all of the ancient Greek and whatever calculations they were doing at that time, ancient Greeks and Romans, they used 22 over 7. He actually figured out a more precise fraction. It was like 356 over something. But this was easier to work with. And you can see 3.14, and if we rounded off pi right there, the 1 would turn into a 2. So 3.142 was is pretty close. And actually the ancient Greeks and Romans did not use decimals. They weren't invented yet. So they did all of their work with circles with fractions. So yay for them. Alrighty, ordering from least to greatest, and this is known as my spelling, oh my gosh, ascending, going up. Okay, and they've given us all of these dudes here. We have an 18%, so this is written as a percent. This one's written as a decimal. This one's written as a fraction, so we can have all different kinds of forms of numbers that actually just mean less than 1. Okay, what does percent mean? What does this sign right here mean? I hope you are saying out of 100. Okay, so they took the 18. You could turn it into a fraction by putting that 18 out of 100. And then to get this decimal, they realized that anytime you're dividing by 100, you're actually just moving your decimal place. Let me grab a different color. There we go. You're actually just moving your decimal place the same amount of zeros but it's getting smaller because you're dividing by 100. So 18 over 100 is 18.18, and I'm not sure why. Oh, I see. They took their decimal and they moved it over, so they were showing you basically the same thing, and they've turned it into 0.18. Okay, they've said that this guy, 22 over 7, or sorry, 22.7%, they divided that by 100, they got 0.227. They converted this one to a decimal, they got 0.25. They converted this one, either they used a Dave for these or they just typed it into the calculator, 6 divided by 5, and this is what the calculator said, 1.2. Now you'll notice that this is bigger than 1, isn't it? Okay, and then their last guy on the end, 0.4. Once you get them all into decimal form, they're way easier to compare. We could take all of these numbers and convert them to fraction form, but then to compare them, you would have to have like common denominators all over the place, and that is very tricky. So if you're going to compare stuff, go ahead and put them all in decimal form, and that way they're way easier to put on the number line. So obviously the 1.2 ended up being our biggest value. It's over here past 1. Whoops, there's 1. This is 1.1. Okay. They've recognized that 0.95 was right beside the 1. And then they know because they've got the benchmark of 0.5 here, they can fill in all the rest. 0.4. They've said that 0.25 is bigger than 0.227 because they compared their hundredths and realized that 5 is bigger than 2. Doesn't matter that there's a 7 on the end of this. They look at their first place value and go with that. And the smallest one was the 0.18. All right, good luck with your comparing decimals and fractions.